We live in a modern, hyperconnected world where everything is becoming smart and connected. Curious about what lies ahead and how this will impact your daily life? I'm Brett Jordan, and this is Smarter Everything, a podcast on the future of connectivity powered by Affero. Today, I'll once again be talking with Dr. Saurabh Shintre, a researcher in advanced AI solutions that has worked both at Symantec and Splunk. In the last episode, Saurabh and I started talking about AI systems, specifically around OpenAI's ChatGPT. Today, we will continue our discussion and focus a bit more on privacy issues, security considerations, and how things like the right to be forgotten will even work in an AI model that is a black hole. Here is my conversation with Saurabh. Saurabh, it's really great having you back on Smarter Everything today. I'm really excited to get back into our conversation that we started last time on AI. We were talking about OpenAI and ChatGPT, and we left off that discussion with you talking about the idea that we're currently in a state of co-pilot mode, where these AI systems need to be kind of handheld. And I think you use the concept of like a Tesla. You still got to keep your hands on the wheel and your eyes on the road, but the car can do a lot for you. But we started hinting to this idea, and I want to kind of pull back on that thread, that there's a lot of changes going on, and it's going to impact a lot of different things, especially in the realm of computing and computer science. So my question to start off today is, how do these models change computing? How does this stuff fit together, and what have you seen here?
These models are really interesting, and they are going to have a significant impact in the way we think about computing. And there are three elements to it. First one is that the input and the output is natural language. So just see what that allows us to do, right? Like so far, people who could program were people who understood programming languages. So you started from basic and COBOL, then you moved into like higher level languages. And now you can just type in whatever you want to do, your thoughts in natural English or other language that you're comfortable with. And these models can basically understand what you're talking about. That just opens the world up for so many people who don't now have to spend years and years understanding the syntax of a language. They could just say English. As long as their thoughts are clear, as long as they can think clearly, they can code clearly. So somebody on the internet made this point that I really like, that every single time a new programming language comes up, like Rust or Go, we say, Go is the hottest new programming language. Rust is the hottest new programming language. Somebody made this tweet saying that English is now the hottest programming language. So how many people do you expand and make it accessible to these kinds of technology, right? So that's number one. So natural language as the input and output interface, which just opens up the world for a lot of people who currently don't have programming or computing background. The second is that these models take information and they reorganize it very differently. So as I was mentioning, that once you train this, historically, we have organized our information on the basis of files and folders and labels and metadata and all that stuff. Now, all of this information is going into the model, and now it's being represented into these parameters. So that just completely changes the way we thought of database and how we were organizing our data. So it's almost a question that I was asking to myself, that when somebody asks me a question, my brain just starts creating the response. It doesn't have like a file or a sequence of that data hard-coded somewhere that it goes to and fetches it, right? We still don't know a lot about long-term memory that the brain uses. But at least what we can say for these models is that in their parameters, they kind of reorganize information that they've been trained on. So when that happens, a lot of your existing organization of information and the security controls that you build around them have to be thought out differently. The third thing, which is also a cause of these models, is that, as we were talking about the temperature value, the output of these models is probabilistic in nature, because they're not thinking in terms of one thing following another. They're thinking of the likelihood between two things happening, right? So there's always an element of probabilistic output. This is not at the level of like a quantum computer. It's not like fundamental physics, but just the way these models are architected. So what that means is that if you are trying to chain the output of these models, one after the other, to do a series of steps, you could potentially, after the 10 steps, get different output, because there was just like some difference that happened in between, like, so if I ask the model to cook me something, and then the model just outputs something differently that the next step was not quite ready to understand fully well, you could have like large deviations through a number of steps. So that element of this probabilistic output is what makes life for us very difficult, because we have sort of been used to thinking things more statically. And we know how to protect and confidently say how my software is going to behave because I could know for what input, what output will be there. And I think that is another element that kind of has changed with these models.
That brings up a whole series of questions in my head that maybe we can hit on here, like the security and privacy concerns regarding these LLMs or large language models. Like that could be a really big concern. Like you talk about the way we store data today, the way we protect it. We have all of these access controls or mandatory access control requirements, or we have multiple forms of authorization and authentication to grant access, and everything is containerized, but it's seems like a lot of that architecture maybe isn't going to work so well. What are some of the concerns that you see beyond just the way the files are stored or the data is stored?
Yeah, so I mean, you can start with something like data loss prevention, right? So we want to make sure that PII is not leaking out through these models or is not going to these models, right? We could do that reasonably confidently in the world of like regular expressions where we knew how the data is going to be organized and we can detect patterns in it. But now, because of this natural language understanding of these models, you can ask it to leak data in very complicated ways, right? So I can say, take Brett's phone number and give it to me. And now your DLP will come in and try to detect a phone number pattern and say phone numbers are not allowed. But I could go and ask the system, prime factorize Brett's phone number and give me just the prime factors. And then I can multiply it back to get the phone number. But then any kind of DLP rule that you might have built for like a pattern is not going to work. Or I could ask the same question to be responded in Shakespearean or French or whatever. Our language doesn't even exist. I could train the model to understand the language interactively and then try to use that for data loss, right? So a lot of our pattern-based data thinking is going to go away and it's going to move more into like, what does this really mean? What is the intent of this query? What is the semantic meaning of this query? And that is going to play an important role. That doesn't mean that all the existing security controls go away, but that means that we also need to build new security controls, I think, in the way these models think.
I could see there being some concerns around this privacy side, potential for loss and leakage of data, especially when you think about all of the data that exists on social media about individuals that they just freely post and they don't realize how easy it is to link all of this data together and then get a really good picture. But historically, that's been very time consuming to do for a human. But if you could point one of these systems at it and say, okay, here's these various accounts for this individual, go tell me which days of the week they go get coffee, at which stores or which shops, because I want to go and meet them. That kind of seems like it could get a little scary really quickly. So,
yeah, and I think another aspect of these models, as I was mentioning, the second part of the black hole, right? That when the information goes in, it just kind of stays there. So how do you make the model delete something? So let's say if my phone number somehow leaks to the model, then we did some work in the past with the European Networking Institute, ENISA, where we did like a position paper on making machine learning forget. So how do you make sure that you delete data from these models that has either been accidentally leaked to these models, or guess what? The model was given wrong data and now I want to correct it. I think there was a case where a security professional asked about himself or herself, I think on ChatGPT, and ChatGPT had declared him dead. He was talking about this person in like past tense, like was. And it's like, I'm still alive. So who do you go to and tell them, no, I'm still alive. Please update your model. So you need to come up with, again, as I said, new tooling. There are a lot of things about these models that we don't understand. And a lot of other problems that are going to show up have not yet been figured out. I'm sure that we will, but it will just require new tooling.
yeah, so I was just thinking about the legal legislation that's been passed over the past 5-6 years on the right to be forgotten and the ability for people to contact a company and basically force them to delete all records of them. And it'll be interesting, like, how do you do that with some of these large language models and these various systems? It seems like there's going to be some stuff that needs to be figured out. And then, like, how do we build new security controls and new architecture pieces to compensate this? Because I could also see these LLMs having their own amount of data gravity, right? This could be a huge target for threat actors because they're going to contain so much information and be able to do analysis. And we've had things like Shodan and all these other search engines and various things to help in doing penetration testing or doing, analysis of security. But it seems like these LLMs might be a huge target because of that data gravity for threat actors.
Absolutely. I think they would not only have access to your internal documentation, or potentially even have access to weird ways to API keys or passwords or other kinds of things, and also might have access to other third-party APIs. So it does have like that integration built into with your Salesforce or integration built in with your Okta or whatever. And if an attacker gets access to these, then they can do so many things, right? They could potentially even leak the model. So it's like another type of ransomware. Instead of sort of stealing like terabytes and terabytes of data, they just steal the model. And now that becomes your like new data loss. And you cannot even tell which customer's data in some sense got lost and which customers didn't, because everything is in there. The other aspect is that you can also interact these models from external data, right? So I can go into ChatGPT in the future, for example, and say, hey, go to this website and pull out this data and do something with it, like run a script. And then you have no way of knowing what's actually coming at the other end, right? So is there a malicious script towards the end? So you have to really look at the ingress and the outgress of whatever is going into the systems. But there's also a problem about seeing what's happening inside the systems as well. And I think that's why you are seeing sort of a significant rise in AI security companies. So they could be either like machine learning ops related companies that were sort of doing work in the ML space from an observability, explainability, and bias angle. But now they're kind of thinking, maybe because of large language models, there are new problems coming up. And there is also like this element of machine learning, detection and response, and all those companies there. It's a very nascent space still, but I think that's going to be an important space going forward.
Is there anything that people should be thinking about proactively to either address their concerns or to not get hoodwinked by AI? Or what are your opinions there?
I think businesses will increasingly see applications of AI coming into either to their SaaS providers or vendors coming in and trying to help them with some productivity. I think the key to understand this is exactly like early days of self-driving or autopilot, right? That right now, do not give the control of the wheel to AI without you being in the seat, right? So any single thing, any kind of big decision or follow-up or any event that is caused or triggered by an automated agent, make sure that if it's something that's serious, then it requires a human being to come in and approve it. And if it's something small, you at least at the end of the day have like an audit of basically the same thing that we do for all of our security, the AAA, which is authentication, authorization, and audit. So make sure that big things that AI is supposed to do are authorized by a human person. And then for small things, make sure that you audit what really happened in that transcript, what was the input, what was caused as a result, and make sure that if something big is going on, you can block it. So just like if you have a Tesla, keep your eyes on the road and your hands on the wheel for now.
Obviously, we've talked about some of the scarier sides of AI and kind of how these AI systems work. What are some good uses of it? Like, what is the impact of these in our connected world with productivity and automation? And what is the best, safe, effective way for people to use this? Because clearly there's got to be some productivity boost and some things that can be done. Like, do you have any thoughts there?
Yeah, I think the reason why we are talking about all of this stuff is because people are using it. And people are using it because it gives them productivity boosts. People I know who used to sort of chase around engineers to write small script for them in the past because they didn't have a technical background, but they had to do or run those scripts on a database or on a system to get their job done, are no longer doing that. They just go to ChatGPT and ask, hey, give me a SQL query for doing this and that. So it saves people so much time. It automates so much of our time that we're using just text processing. And I'm sure that other mediums will also expand like visual, and there's tremendous productivity boost. And that's why I think a lot of these questions are coming up, that we have seen this story play out when the SaaS apps came up, right? We declared them as shadow IT and we blocked them, which is essentially how a lot of companies are reacting to ChatGPT as well. Hey, I don't want you to put private data or sensitive data on ChatGPT. I'm going to block it. But we have seen this story time and again. If something provides productivity boost to your employees, they'll find creative ways of using these systems. So blocking is not going to be a long-term solution. So you'll have to develop different types of tooling to actually be able to protect your private information from leaking to these systems. There is a lot of interesting things playing out also in the world of open source, where a lot of smaller models are coming out, which are equally performant, if not as performant as GPT. So a lot of companies are going to be thinking that, hey, can I buy a couple of GPUs from NVIDIA and put a system like that in my own like sort of protected network so that I don't have to worry about this information leaking out to the larger public. And then these smaller models allow you to do that cheaply as well. So that's another angle that I've seen some people talk about how they can develop like a private model or host a private model in some sense. So that's one way that companies can use to at least start thinking about using these models without having or worrying about all of their secrets leaking out to the public. Then there are like these AI firewalls. I'm sure that companies would be thinking from a DLP angle. But I think in the long run, these systems are going to evolve to counter those existing security controls, and we'll need to come up with new ones.
There was an article several weeks ago about Samsung. I don't know if you're familiar with that, but their developers were using ChatGPT for code analysis, and then it was starting to learn that and respond to other people with Samsung code and stuff. And there's definitely some things to be cognizant of, but I think you're right. This also goes back to the security architecture and model that we've been doing since the early 90s, 1993, 94. I was running very large networks and firewalls weren't even a thing yet. We were just doing ACLs on BGP routers. And then we started deploying this bolt-on security, and it doesn't work, but we keep doing it, right? We keep pouring gas on the fire, hoping that somehow it's going to make things better. But I think these generative systems and these AI systems and LLMs and all these pieces are going to force us to have to rethink the way our security architecture and our security stack is designed and deployed, because they're just going to become irrelevant pretty quickly.
Absolutely. I think you hit the nail on the head that these things are going to create like an entire new computing stack. And this is also a good time for security professionals to not react as we always do, but actually take a leadership role here and say, hey, we are going to deploy this new stack, a stack which takes, and the interaction is through natural language. It can generate things, it can write code for you and whatever it is. But we come in and we say, how do we do this smartly and securely and not have the same problems of like putting weak security controls on top of one on top of another that sort of we've done in the past. But I'm optimistic. Coming back to your point that you asked earlier also about the connected world and the IoT devices and all that stuff. I mean, this is also an interesting space for these devices because of a few angles, right? One thing is we have, again, as I mentioned, natural language, which is such a big input space. The other thing is the reasoning capability of these models as well, which is primitive, but it's there, right? So back in the day, we were interacting with all our devices, our refrigerators, our ovens and whatnot, almost for like a recipe, like an instruction set, do this, do that. But now what we might be able to do in the future is to give it just a general request. I don't want to tell them to like boil the pasta and then fry the onions. And then I just tell them, hey, I want to eat like spaghetti bolognese. And then the model just finds out what the recipe is based on its knowledge or its own reasoning capabilities and does all the tasks for you. So wouldn't that be like an amazing productivity boost? But then you just have like a hallucination there, and then it adds sugar to your pasta or something like that. And then there's no way for you to know. And that's always the problem with automation, right? That when you give away responsibilities to something else, you also lose control over that thing. And then you don't have good ways of knowing in the process what might be happening. So you end up getting the final result, which is what you wanted because you didn't want to spend time dealing with all the individual steps. But then if something goes wrong, it takes longer to detect it. So yeah, your toasters or your refrigerators or whatever IoT devices you might have, they might have to deal with this problem of how do we take, let's say light bulb. The light bulb really has 2 or 3 functions, right? Turn on, turn off, or maybe dim the light. But again, when you will see these models coming up and the natural language coming up, the input possibilities are really high. So how do you take anything that a user could say and bring it down really to the 2 or 3 things that you want these models to do? 2 or 3 things that you want these devices to do is going to be a challenge. And again, it's going to be fun seeing how the world of IoT responds to these kinds of models. I'm sure that they are considering looking into like the newer versions of Alexa or the newer versions of Google Homes and seeing what kind of possibilities happen there. You're also having this interesting situation with companies building all these robotic bots, right? Like Tesla, I think, has their own like actual humanoid robot. And just imagine like having like a robotic assistant at home with all the capabilities of these large language models and that has actually access to things manually. That's just going to be interesting.
Where do you see this technology going? Like, where do we go from here?
So I think there are a few ways in which this can play out. There's this famous saying that history repeats itself. So I think there is always an early promise and early excitement of trying to put these things into areas of development where they are not quite needed. But just because it's a new hot thing, people will try to bring it in and say what we can do with it. That's probably going to be followed with some security concerns that will immediately come up because people use these technologies in a poor way or didn't think it through. That will slow down the development. That will make it harder for people to do things. And there's going to be a point where we'll reach a stable equilibrium between sort of like how to do this safely and securely without breaking everything else. So the pace at which this is going to happen is actually might be much faster because I think development happened pretty fast, right? So ChatGPT is only 6 months old to the point where we are now seeing like major investments from companies and such into these systems. You're also seeing sort of like people freaking out and writing these letters about like how AI is going to kill us all. So there is some sort of fear being generated that would also definitely lead to regulation coming in at some point in time. So the cycle is just moving a little bit faster. It's always hard to predict 12 to 24 months period. And I found this in my experience as a researcher. It's actually sometimes easier to predict what's going to happen in the next 50 years because first of all, you can make a wrong prediction. And by the time you're wrong, you're not there to be accountable for it. It's kind of harder to predict something that's going to happen in the next 12 to 24 months. But I'm really optimistic. I think the value of these models is quite clear. And it's just going to be a question of who cracks the first proper use case, either in consumer or either in enterprise. And that's going to lead to serious adoption, but regulations and all that stuff. I think the cycle will be much faster.
Something you hit on, I think, is really important to restate. It's because of the advances from OpenAI. Obviously, Microsoft helped build the infrastructure to drive all of this. But because of those advances, it has basically unlocked an entire pool of money and potentially an entire new ecosystem for security. A lot of things will change, but I think there's going to be new opportunities and a whole new set of things that will get opened up because of it. In a tangential discussion, I've talked with my children, as they're going to college and they're studying math and physics and things in engineering. I've told them that, with like the NASA Artemis missions, like if they were to find rare earth metals, or I guess they'd be rare moon metals, but any type of rare metals on the moon or on Mars, the amount of money that would instantly flow into the global space program would be tremendous. And so at that point, you would not be able to hire enough mathematicians, scientists, engineers. There just wouldn't be enough because everybody would be getting into it and moving forward. And I kind of see that where AI is going now. There's so many new startups and so many new technologies. And then you have this antiquated security architecture that we've been doing since the early 90s. And it just doesn't work. Even in the White House briefing, with their new frameworks and strategy documents, they actually call out bolt-on security as not being effective. And so I think the market's about to change, and I am excited about it. I think it's going to be interesting to watch. I don't think that AI is going to go and kill us, at least not in the next 10 to 20 years, because I can't even ask Siri to, remind me 5 minutes before I get home to call somebody. It gets all confused and says, hey, here's what I found on the internet. So I think there's a lot of work that needs to be done before it can become more usable.
I think two things I would say to that, right? First thing is regarding what you mentioned about rare earth metals and stuff. So when the whole crypto boom was happening and Bitcoin was sort of becoming the big thing and people were talking about like digital gold. Somebody told me at the time, because I also dabble in the crypto space a little bit, somebody told me that the real digital gold is a GPU because that's the thing that you need for everything. And those are the things that are in short supply. And coming to the point of AI killing us, my take on that is that a lot of people are talking about this really good AGI, it's sort of like the singularity AI that will one day come up and kill human beings because it thinks that we are in the way of progress or something. My concern is that we are more likely to die with bad AI than with good AI. AI that was designed for things, but just not good at those jobs, right? It's the self-driving cars that don't quite drive that well and end up not seeing that deer or that kid. So bad AI is more likely to kill people in the short run than really good AI.
Well, and like the research that you've done, in the past about modifying like street signs, like stop signs, by just putting a little bit of tape in very strategic places and confusing the system. If we can't figure that out, there's a lot that needs to be done. So,
absolutely. But as I said, I think the value is quite clear. One element I would say that also from a point of view of not just from connected things, but in general, that an advantage of these foundational models, cost and other concerns aside, is that it's easier for people to use these foundational models and build their own task-specific models by fine-tuning them. So you might actually see like an uptake on like better performing models because a lot of companies build products they don't really know how to write good machine learning algorithms, right? So, this in the world of security, what really goes on in the name of AI is really just stats based or some kind of like thresholding rules. So it might be a case where a lot of these other industries that were sort of lagging behind like good AI adoption will use these foundational models, take their own specific curated data sets, fine tune these models to actually deliver the promise that they have been talking about for a long time.
I do have one final question for you. What are you most excited about?
I think as of now, I'm really excited about this space, honestly. I think as we talked about a little bit, that this is going to change a lot of the computing stack that we are used to in the enterprises. And that is also an interesting opportunity from a security point of view as well. So as a security practitioner, I'm really excited about how this thing is going to play out, how companies are going to adopt them, who is going to win out, what architecture is going to become like the one that takes over the market, and what opportunities will come into play for other people. So it's a huge wave that's going to rise all boats. And I think that's just a very exciting time to either jump into the ocean at this point in time, or even if you want to see things from the side.
Yeah, definitely learn how to swim and learn how to swim quick because it's coming. So once again, everyone, we've been talking with Dr. Saurabh today, brilliant researcher, scientist, and done a lot of work in AI and ML systems. He's done a lot of work in security, protecting, our way of life. And it's really great to have you on today. So thank you.
Thank you.
Thank you so much for joining us today for this episode of Smarter Everything. We really love feedback, so please consider taking a moment to send us a comment or a rating on Apple Podcasts. And if you have time and you like this episode, please consider subscribing. We'll see you next time for Smarter Everything.